now my pleasure to invite Håkan Eriksson to the podium. After a long career as both CTO and CEO of Ericsson Australia, is there a relation there? Håkan joined Telstra as Chief Technology Officer earlier this year. Please welcome Håkan Eriksson.
Thank you. And now it's going to be almost a little bit of content switching, I guess, back to the technology space and IoT, and just basically how we will connect all these things. And I agree, there are lots of things, and we have to think about all the data, where it's all going to be, because the things are basically going to be two kinds of things. They're going to be sensors and activators, and it's all going to be sent in to the network somehow. And if you think about it really, and you have read about that also, I mean, if you think about it, almost this whole Internet of Things will almost be like a big human body, because we are also basically made out of only sensors and activators. But we have decided to do everything centrally in one brain, and everything goes in centrally, and we do nothing. We don't have one brain in each knee to decide how we walk. We bring everything in centrally. Maybe that will not be the way we do the Internet of Things. We actually will execute a lot on the edge that we don't do in the human body. So that is a big discussion. So we don't always have to follow the way the biology has figured out is the optimal solution. You can also see that from another invention that we have done is the wheel. There's nothing that in nature that really represents the wheel. So there are things that we do differently, so we don't have to copy biology all the time. But that's not going to be the main thing. My main message here will be around what technology shall we use to connect all these things, and then a little bit about the devices and the different application layers in the ecosystem of IoT. First, about the different generations in cellular technology. Because one of the things that is most talked about for 5G almost is that 5G is going to come here for the things. Because if you look at the performance of 4G today, you could say if only humans would be using the cellular network, we could basically almost stop with 4G. With the 5G, it's for the things. Some of the requirements we have there, the latency requirements and so on, are so tight. So it's sort of, if we introduce the human reaction time in things, you don't really have to improve it that much, because it takes a second for a human to react, and we are improving with going from 4G to 5G. We are improving the latency from 10 milliseconds to 1 millisecond. But if you add 1 second human reaction time to it, it doesn't really matter. So it's really about the machines. But my point will be in the next slide that we don't have to wait for 5G. We can do a lot already on 4G. So if you go through the different generations, there has been one generation every decade, almost like clockwork, the last 30, 40 years. The first generation came in the 80s, only analog voice. Second generation started. The new thing that really came was, of course, it was digital, but we got the message to send text messages and SMS with second generation. Third generation was about increasing the bit rate and get for mobile broadband. And if you look at the speeds there, you almost increased the speed factor of 500 when you go from 2G to 3G. And then dramatic speed changes again. But now 4G was quite easy, because with 3G we introduced mobile broadband. 4G was just a better mobile broadband. And now 5G, what are we going to use 5G for? That's sort of, well, we are increasing the speed again. There are basically 5 things that's going to happen with 5G. Increased speeds, increased capacity, shorter latency, the possibility to connect many, many more devices, and also the way to create what we call network slicing, so you can create certain slices in the network. And a few of those are basically the latency, the many devices, and the slicing could be important for IoT. But if you think about it, it's really for the latency requirement is really for certain very mission critical. So there is basically, if you look in the 5G standard, there are 3 different categories: mobile broadband, massive sort of IoT applications, the sort of the cheap solutions for the many things, and then the mission critical application where you really need it for something unique. And that's where you have the 1 millisecond latency. But if you compare with how long does it take, if a car is driving at 90 kilometers per hour, it's about 20 meters per second. So in 10 milliseconds, you get 20 centimeters. In 1 millisecond, you get 2 centimeters. So that's the difference between 4G and 5G. Does a car get to drive 20 centimeters or 2 centimeters? So it's not all applications that need that short latency. If you have lots of moisture sensors in a farm to see how moist is the ground, 1 millisecond, 20 milliseconds, the grass won't grow that fast anyway. So those applications you can go with the sort of more the massive application. But if you want to remotely drive a truck or something, maybe the 2 centimeter is better than the 20 centimeter. However, with all these beautiful things coming from 5G, there are lots of advancements happening already on 4G. 4G started out as a technology sort of for mobile broadband only around some megabits per second, and has evolved in 2 directions. One direction is out to the left here, where it's sort of gone to gigabits per second, what we call the Cat16, where that's sort of for being able to download Netflix movies or do anything on those kind of speeds. Then it has evolved in the other direction to what we call Cat M1 and narrowband IoT that are really for the IoT applications. And the beauty of that is basically a software upgrade of the 4G network. So we at Telstra now, we have turned on the M1 and we are about to turn on the narrowband IoT. Telstra's 4G network is covering 99.3% of the population in Australia. So when we do that software upgrade, 99.3% of the population is already covered with the world's largest IoT network. It's already there. So now we just have to build the devices underneath that, but the IoT coverage is already there. And what are some of the unique features with those? First of all, it's for the devices, it consumes much less power using the narrowband IoT. The other thing is that the link budget is much better. So if you have good coverage on the street and then you walk down in the basement of a house, and maybe you have less good coverage down there for various reasons, and using narrowband IoT, you will have as good coverage down in the basements as you have out on the street, which is a good thing if you are a device sitting in the basement. As a human being, if we have bad coverage, we can always walk up to a window and continue. The little device in the basement cannot walk to the window. So that's why the narrowband IoT is a good thing. So using the 4G network already now to deploy IoT applications. So don't worry about the network. It's there. So there are a few different kind of devices that might require different IoT connectivity. So basically we here have 3 different categories. If you start down in the obvious one, that is the mobile broadband connections for services that require high data throughput, low latency, and so on. They could be powered and more short battery life. Then if we move up to the top, there we come to the applications that want to have long battery life. That doesn't need so much bit rate. And there is where these narrowband IoT and Cat M1 applications come into play of the 4G network. There are also other standards proposed, Sigfox, LoRa, and a few others, that are using the non-licensed spectrum. The thing with those standards are that they are out on the device side a little bit earlier than the narrowband IoT and Cat M1. But in the long run, you will have, the negative thing is that you will have to build a new network. And the cost is really sitting in the network. So compared to just doing a software flick of a switch on the 4G network and have 4G coverage, IoT coverage already with the 4G network, to build a new network just for IoT, usually it's a very, very different business case to meet. So our strong advice from Telstra is, of course, that you build your IoT applications using devices connecting to the already existing 4G network. And then, down in the right corner, there's the connectivity that probably will connect most of the IoT devices. And they are the ones that you do in a very, very local environment where you use Wi-Fi, Zigbee, Bluetooth, and other technologies. If you look at the Telstra smart home, for instance, you have some kind of connectivity out of the house, but every little sensor that you have on every door and so on they do not have 4G in them. They use Zigbee or other technologies to connect. The cameras are using Wi-Fi to connect to the hub. So there will be a lot of devices. I mean, when you start having every light switch every light bulb being a smart device, they will not be all 4G devices. So there will be a lot of short-range communication. Then out of that, you will use either some fixed connectivity or cellular technology going out of that environment. So 4G in those two, and then a lot of short-range communication, cordless communication, and then using fixed or 4G, 5G, getting out of the bubble down in that corner. Then there is a whole ecosystem, and here there will be various players involved in the different layers, and also there are some characteristics running in the background that will be important. If we start with security, security will be very important, especially for some applications. Imagine when you are relying a lot of all this data that is coming from all your sensors and then go through your system and they go up in the cloud, but they are important for your business decisions and things. There might be so that the company will be audited, and somebody comes in and audits you and says, all this data that you're basing all this on, has that really happened? Well, I don't know. It was sort of some unregulated, unlicensed radio, and then sort of it ended up in the cloud. And so maybe you have to have an encrypted link. It has to be maybe blockchain encoded all the way, so you have it, so you can actually know that when you pull down the data again, that this is actually data that I can stand for, and I can be audited on this data. So the whole security, not only for various data breaches, but also actually for running a business in a governed way. Then services, end-to-end, that works end-to-end, will of course be fundamental for running your business. Then the 4 layers. If we start from maybe from the network almost in the middle, the network, that's why I talked about the network, where you have 4G connectivity, later 5G connectivity for all these devices, or they are short-range communication, Bluetooth, Zigbee, and then using fixed over NBN or some cellular connectivity to get into the cloud. On top of that, platforms for various things. For one is for just authenticate the various devices. There will be different platform suppliers, and I think here we have to have an ecosystem, because there will also be coming players globally into Australia. Maybe one car manufacturers have signed up with some platform for their brand globally, and now they want to bring this platform into Australia, and some other manufacturers signed up with somebody else and they come into Australia. So we have to be able to accommodate all these different platforms in a platform of platforms, because we cannot dictate which platform to use if this big brand has decided what they want to use when they come to Australia. On top of that, all the applications, and of course that is where we will have a lot of development happen, and that's I think where most people participating in this industry should spend their effort on the applications and try to reuse the layers below as much as possible, not keep reinventing, because that will just waste a lot of money. So use the platform and spend the innovation where you can differentiate on the application layer. We will not participate in every application. We will partner a lot. We will go for a few applications where we will go deeper, but not in everything, because that's going to be a very, very widespread area that requires a lot of different competences. And then down in the bottom, all the things. And those things will of course be very different, but they will all have some kind of connectivity module to them. And those, there again, we have to rely on the scale of the industry, on the modules. The same way, the reason why we can buy a smartphone, even though we think they're expensive, but they are quite a remarkable thing. The reason why we can do it at the price level we can is because of the scale. So we have to rely on the scale again when you come down to the modules. And if you look where China is going on narrowband IoT, 4G narrowband IoT, that's going to be huge, huge volumes on narrowband IoT coming. They are doing it on 800 and 900 megahertz. We have a 700 megahertz network here, but that's easy to change the carrier frequency. But we can write on those volumes when it comes to the modules for the devices also in Australia. Then finally, to work in this ecosystem with all these different layers, we realized that we have competence on, say, the module level and the network layer, and partly on the platform layer. We don't have competence in Telstra on all the application layers, be that health, agriculture, transport, whatever, pick whatever industry you want. And we assume that since we have spent so much time being experts in network, that people that have spent time on being expert in agriculture or transport, they do not know everything about the network. So there's a need for a meeting place where we can meet and share competence and also test. If you have an idea of how you want to build a module for the IoT, somebody wants to come and test it, you can come to Telstra and test it. We have in Melbourne an open IoT lab where we have a controlled radio environment. So if you want to test, if I build my module like this and I'm going to put it in somewhere like this, how long will the battery last? If I I want to put it on pallets that go across Australia, how will the handover algorithm work when it moves from one base station to the other one? Will that work? How big does the antenna have to be? The battery size, the power amplifier, all these things if you're working on some kind of module. You can come and test it in Melbourne. We have an open IoT lab where we have an environment where you can do it under controlled forms. So that is more of an invitation to the ecosystem. We know the network layer. We have by far, of course, Australia's, but also we think covering 99.3% of Australia's population. Is a big continent. We don't cover the whole continent, but a large part of it. We think we have the world's largest IoT network, and by far the largest IoT network in Australia. And we wanted to invite you to come and test how your applications can run on that network in our IoT lab. So with that, I conclude my more technical approach to IoT and welcome you to Melbourne. Thank you.